Hello, and thank you for joining me. My name is Michael Murphy. I'm a meteorologist and a climate program leader at the National Weather Service in Pendleton, Oregon. Today I'll be talking about ENSO, El Nino, and what effects some previous strong El Ninos had on the Pacific Northwest. A strong El Nino is generally defined as having a sea surface temperature anomaly of greater than plus 1.5 degrees Celsius in the Niño 3.4 region of the tropical Pacific Ocean. Again, a strong El Nino is not referring to the strength of any particular storm system or series of storms. The above diagram shows the average temperature anomaly from November to March during 6 previous strong El Nino years. During these 6 strong El Nino years, averaged together, there was a fairly strong signal for above normal temperatures across the northern tier of the U.S., including northern Oregon and southern Washington. Moving down towards central and southern Oregon, temperatures averaged out within 1 degree Fahrenheit of normal during these years. The above diagram shows the average precipitation anomaly from November to March during 6 previous strong El Nino years. During these 6 strong El Nino years, averaged together, there was a signal for below average precipitation in parts of the Northwest, including the Cascades of northern Oregon and Washington. Other areas in the Northwest generally saw near normal precipitation when averaged over these 6 strong El Nino years. From California across all of the southern U.S., precipitation amounts were above average due in part to the active subtropical Pacific jet stream. As seen in the previous slides, temperatures often average above normal in the Pacific Northwest during strong El Nino years. However, I wanted to show this example that not all strong El Ninos are exactly the same. Sometimes other factors can tilt the weather pattern a different direction. For example, the above image shows wintertime temperatures during the strong El Nino year of 1972-1973. It can be seen that much of the Pacific Northwest finished the winter in the coldest 20 to 40% of all years, dating back to 1895. Quite the opposite temperature signal that one would typically expect during a strong El Nino year. The above image shows another example of when a strong El Nino did not follow the rules. Even though, as seen on previous slides, the Pacific Northwest typically sees near to slightly below average precipitation during strong El Nino years, 1982-83 was much different. During this strong El Nino winter season, most of Washington and Oregon had well above average precipitation amounts, ranking in the top 90% of all years dating back to 1895. During 7 strong El Nino years sampled, Pendleton had 6 below normal snowfall seasons and 1 above normal season. The average snowfall during these 7 strong El Nino years was 8.8 inches, compared to the overall 30-year average of 14.1 inches. Therefore, Pendleton averages about 5.3 inches below average for snowfall during previous strong El Nino years. During 7 strong El Nino years sampled, Bend had 6 below normal snowfall seasons and 1 above normal season. The average snowfall during these 7 strong El Nino years was 17.6 inches, compared to the overall 30-year average of 22.5 inches. Therefore, Bend averages about 4.9 inches below average for snowfall during these previous strong El Nino years. During 7 strong El Nino years sampled, Yakima had 6 below normal snowfall seasons and 1 above normal season. The average snowfall during these 7 strong El Nino years was 14.6 inches, compared to the overall 30-year average of 19.5 inches. Therefore, Yakima averages about 4.9 inches below average for snowfall during previous strong El Nino years. The result is fairly consistent across the lower and middle elevations of our forecast area, with below average snowfall totals overwhelmingly winning out in many of these previous 7 strong El Nino winters. This concludes part 2 of our briefing on ENSO. Please continue to visit National Weather Service web pages and the Climate Prediction Center for the latest weather and climate information. Look for part 3 of this series to be released on our webpage and via social media very soon. Thank you for your time.